Now we will be covering example A. The introduction to example A says, adding polynomials using algebra tiles can be done by modeling each polynomial, identifying and removing zero pairs, and writing the new polynomial. Example A has been worked out for us. We're actually going to dive into the try these A. I'm going to go ahead and get another piece of paper so that I have some room to write these down. And again, I'm going to write these on a separate piece of paper, but I am going to show my steps, sorry. Show my moves. So try these A. The first one says x minus 2 plus 2x plus 5. All right, I'll set that off to the side. Now, remember we had three different types of algebra tiles. We had the big square, which was the x squared. We had the rectangle, which represented x only. And we had the small square, which represented plus 1. Okay? Well, do I have any x squared in this first expression? There's no x squared, right? But I do have an x term. So I'm going to have one of these rectangles. And it's going to say x, right? Then I have two of these little boxes with no letter, but they're going to be negatives. So I'm going to put a -1 in them, and then I'm going to go back and highlight them so I know that they are negatives. Like such. Okay? Now we're going to look at our second expression. Our second expression says 2x, so that means I have two of these. So I'm going to do 1, 2. Then it says plus 5. So I'm going to have 5 of these little boxes that have the ones in them. So I'm going to say plus 1, plus 1. We're going to do plus 1, plus 1. And then I got that fifth one, plus 1. All right. So the first thing we did was we modeled the polynomials. Now it says identify and remove zero pairs. So if they add up to equal 0, well, notice how x, x, and x are all the same color. So they don't zero or cancel out. Okay? But notice I have a -1, a -1. These are highlighted. But I have two that are the same but positive. So what we're actually going to do, and I'm going to nope. Sorry, I'm looking for a marker of some sort. Because what I'm going to do is I'm going to cancel these out, but I also have to cancel two of the positives out to basically zero those out. Now this is what I'm left with. 1x here, and I can put these x's with it. Then I have 1, 2, 3 of these little squares, all positive. So if I write this as an expression without the algebra tiles, we have 3 positive x's. So I've got 3x. And I have 1, 2, 3 positive ones. So I would rewrite this answer as 3x plus 3. Let's take a look at B. B says 2y squared plus 3y plus 6. And then I have 3y squared. Oh, sorry, there's a plus sign here. Minus 4. Well, y squared, x squared, it just means that the term is squared. So I can still use my little algebra tiles here. All right. Again, these are going to be represented by those bigger squares. So I have 2 of them. I'm going to call them y squares instead of x squares because that's the letter we're dealing with here. Then I've got 3 rectangles, which we're going to call y. And then I've got 6 small squares. Now, all of this stuff was positive, so I'm not going to highlight anything. Let's move on to the next set. I'm going to have 3 of the big squares. And we're going to call them all y squared. And then I've got 4, but these are all negatives. So I'm going to do minus 1, minus 1. Got to do these down. Minus 1, minus 1. I ran out of space. And remember, I'm going to highlight these because these were a different sign. These were all negatives. Now, can any of my y squares cancel out? No, these 2 were positive, and so were these because they're not shaded. The y's were all positive because they were not shaded. However, I have 4 shaded over here, and I have at least 4 of the positives to zero them out. So I'm going to cross off 4 of these, and I'm going to cross off all 4 of those. So that leaves me with 1, 2, 3, 4, 5 of these y squares. So we're going to redraw our y squares. Y square, y square, y squared, y square, y squared. Okay. Then I've got 3 of the rectangles. So y, y, y. And then we have 2 of the small plus 1s. So I would write this as 1, 2, 3, 4, 5. 5y squared. 1, 2, 3 plus 3y. 1, 2 plus 2. So that's the answer I'm going to transfer over here. 5y squared plus 3y plus 2. All right. Let's try to fit C right here. C says 2x squared plus 3x plus 9 plus negative x squared minus 4x minus 6. All right, so we're going to start over here. We have 2 of those big squares. We have 3 rectangles. And we have 9 of the small squares. Okay, now we're going to do all of our second expressions. So we've got 1 of our x squared boxes, but it's negative. We got 4 of our rectangles, but they're negative. And then we got 6 of our little squares. Again, negatives. And I'm going to highlight all of this in that second set because those were all negatives. Okay, now we're going to go through and we're going to zero out anything that we can. Well, I have one of these and one of these, right? I have 1, 2, 3. 1, 2, 3. I've got 6 of these, right? So I can cancel those out. So let's take a look at what's left. We have 1 of our x squares. We have 1 rectangle, but it is negative. And we have 3 of our small squares. And I want to go back and I want to highlight this because remember, this is still negative. So I'm left with 1x squared. I got a negative x. And I got 1, 2, 3 positives, no variable. So we've got x squared minus x plus 3. All right, so now I need another piece of paper because I've ran out of space on this one because I still have to work through D. So I'm going to move this off to the side. We're going to go through D here. This is 5 minus 3x plus x squared plus, the second one's got 2x plus 4 minus 3x squared. All right. So we got positive 5. So these are my little squares, remember? Now, based on the last lesson, these are obviously not written in descending order, so they're not written in the standard form, but we can still work with them. We've got the negative 3x, so these are going to be our rectangles. Notice how I'm putting that negative x on each one of these. And I'm about to do my highlighting of them to represent the negatives. Like so. And then we have one big square. Okay. Now we're moving into that second set. Again, still not written in standard form because they're not written in descending order, but I can still work with them. And we got 3 big squares. So negative x squared, negative x squared. I'm going to put this other one right here because I ran out of room. And all these need to be highlighted because those are indeed negatives, right? All right. Let's see if we can cancel out anything. Well, these ones are positive, as are these ones, so I can't cancel those out. I do have some rectangles of both shades, so I can cancel out however many zero us out. So I can cancel out 2 of each. Okay. I have 1 positive x squared, but 3 negative. Well, that means I can only cancel out 1 to zero it out. I want to write these in descending order whenever I finally make my answer. So I'm going to actually put my big squares at the beginning. So I have 2 of them, but they will be shaded green in the end to represent my negatives. So I'm going to go ahead and shade those to indicate that they are indeed negative. Okay. I have 1 of the rectangles left. It is also negative, so I will need to pull out my highlighter one last time here and highlight that green. And then we have these 5 squares with these 4. So I got 1, 2, 3, 4, 5. Now I need to make these 4. 1, 2, 3, 4. So that makes my final answer. Negative 2x squared minus x. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these. So plus 9. So negative 2x squared minus x plus 9. Negative 2x squared minus x plus 9. All right, go ahead and take a moment to copy all this information down. I know this was very detailed in this section, but go ahead and get that section done. And then answer the debriefing question to follow.